Okay, what we did in class today was try to get you ready for a quiz that's going to be happening this week. It's quiz 3.2, and it'll cover chapters 10, 11, and 12. And in a lot of the stuff that you'll be dealing with, you're going to have to use a balanced equation to get mole ratios. And so I thought we'd just check out and see a little bit easier method to balance equations that I saw in a video recently, and I kind of liked it. What we have done in the past is had two lists of elements. The elements that are listed on the left side and on the right, which of course have to be the same elements. And our job, of course, is to get them the same. Well, instead of putting numbers over here, like if we were balancing zinc, we'd have one over here and one over here. It makes it a little bit easier if we do something like this. First of all, we'll just get rid of this, and let's make two lists in one. And now we'll list the left-hand stuff to the left of the element and the right-hand stuff to the right. So let's go ahead and look at zinc. On the left side, you'll see that you only have one zinc atom. On the right side, you also have one zinc atom. Your manganese on the left is only one. The manganese on the right is a 2 because you have that subscript in there. And so we have 2 on the right. Now, when we get to oxygen, we have to be a little careful because we have oxygen in 2 places. So I'd like you to try that on your own. So stop the recording now and see if you can get the balancing for oxygen. And don't balance it out. Just put down the numbers that as they exist right now. Okay, stop the recording. Okay, let's come back now and see exactly what we do. We've got two guys here, so that's 2 times 1 is 2. We only have 1 oxygen here, and that gives us a total of 3 oxygens on the left. And over on the right side, we've got 2 times 1 is 2 oxygens from the zinc hydroxide, and 3 oxygens, 3 times 1 here. So 3 and 2 gives us a total of 5 oxygens on the right. And then we go to the hydrogens, and on the left side here we see a 2. Over here we see 2 times 1, which is 2. So our hydrogens are actually balanced. So we've got a problem here with getting the oxygens balanced and also oxygen and the manganese. So let's go ahead and start with the manganese. So what do? We have 2 manganese on the right, and we need to get 2 here. We can do that with a coefficient. So we just put the coefficient here, and now we have 2 manganese. But what did we do? We added, we made 2 here on the left, but we also have 2 on the right. And so we added 1 more, or we could say something like 1 times 2, which is what we did with the coefficient, is equal to 2. And let's fix that, make it look better. That's right. There we go. So we had 2 there. Now, on the oxygen, again, we've got to be a little careful. We got 3 on the left, and we put this 2 here, which added 1 more oxygen, or added 2 more oxygens. So when we add 2 more oxygens, notice this time I'm adding instead of multiplying, because oxygen is in 2 places, and when I multiply anything here, it does not multiply it over here. So we wound up with a total of 4 plus 1 is 5, but in our little method here, we're just adding in the 2. And so that gives us a total of 5. Whoops. Alright, let's put the 5 in. So now we have 5 and 5, 2 and 2, 2 and 2. I was just reading these guys here. So the manganese is 2 and 2, the oxygen 5 and 5, the hydrogen 2 and 2, the zinc 2 and 2. And now we're free to go ahead and put 1s in all of the blank spaces. And now we are balanced. Okay, what I'd like you to do now is tell me how many fractions you think there will be if we take this 30 grams of manganese and convert it into grams of zinc chloride. So I'd like you to take a minute, turn off the recorder, and see if you can get the big picture, which is what we're going to do down here in this line. And I want you to remember that these are all factors that we have used so far. Some of them or all of them will apply to this problem, but not necessarily all three. So take a minute and see if you can get the big picture. Stop the recording. Okay, now that we're back, let's look and see how you did. Your given over 1 would be the mass of the manganese, correct? So that's your given. And that would always be the mass of manganese over 1. And then we would convert that into moles of manganese. And here, let's put in these guys as we go. The chart's going to take us from our mass, into moles. And then we're going to have to get moles into moles. Okay, where did this come from? These guys, the ratio is going to be there in this guy. We're going to have a mole ratio to get us into this guy. And once the chart has given us the moles of manganese, then we're going to use the mole ratio to get the moles of zinc hydroxide. So that's what's going to be there. And the mole ratio will be whatever we have in the balanced equation. So let's look back and see what that balanced equation looks like when we're taking manganese dioxide into zinc hydroxide. So our arrow connecting them will look something like this. We're going from the manganese dioxide to the zinc hydroxide. So let's look back now over on the right side, and this mole ratio, of course, is going to be a 2 to 1. 2 manganese dioxide to 1 zinc hydroxide. And by the way, I've been calling this manganese dioxide. That's just a little wrong. It's actually manganese 4 dioxide, because that would be the charge on manganese. So back over here, we're going to put, when we get back on this side, we're going to put the mole ratio here, and that will get us into manganese hydroxide. And then the last thing is to convert, and we're going to use the chart again, this time to get zinc hydroxide moles into mass. And the mole ratio, or not the mole ratio, but the chart will give us that conversion, how many grams of this there are in 1 mole. And over here, it was how many grams of this in the chart is equal to 1 mole. So this is our first fraction, second fraction, third fraction, fourth fraction, which is what I was trying to get you to figure out up here. So now you've pretty much got it, and now we go to actually doing the problem itself. So what we're going to do is, let's get this one guy out of the way. Let's go ahead and start our calculation. Let me get us back to a single screen, and we can go ahead and start with the given over 1 like we always do. So we've got the mass of manganese is 30.0 with 3 sig figs manganese dioxide over 1. Okay, next comes the chart. And let's just take the chart right here. This is kind of a good thing. And we're going to figure out the molar mass of manganese dioxide. Whoops. Manganese 4 dioxide. And I had the wrong subscript there for the oxygen. 2 Okay, so let's go ahead and figure that molar mass. So once you calculate that out, you'll find that's 86.9 grams of manganese dioxide is equal to the 1 mole of manganese dioxide. Manganese core dioxide, I should say. Now, our next little fraction is going to be the mole ratio. So the mole ratio in the balanced equation showed us that we had 2 as a coefficient for manganese dioxide, manganese core dioxide, MnO2. And then we had a coefficient of 1 on the zinc hydroxide. And that would be a mole again. So that's 1 mole of zinc hydroxide. And then the last thing that we need to do, and let's take the mole ratio thing, and let's label that fraction. And this fraction was actually the given. Given over 1. That's how we're going to wind up getting our 4 fractions. And then we're going to have the chart again here, and we'll figure out what the molar mass is for the zinc hydroxide. So after running that calculation, we found that there was 99.4 grams of zinc hydroxide in every mole of zinc hydroxide. And that, of course, required the chart. So you can see we went from the given over 1, first fraction, chart, second fraction, mole ratio, third fraction, chart, fourth fraction. And now all we do is run the calculator. So please stop your recording now, calculate it out for yourself, and see if you come up with the right answers. And then I'm going to show you a very neat way to calculate these things quickly. Now before you go any further, you need to write down the balanced equation, which is over on this screen, and have that with you so I can refer to that with you as I show you my neat little method. Okay, turned off now, and give it a go. Okay, that first fraction had 30 on the top, so that's what you put into your calculator. So what you put into your calculator as the first number will always be considered the top of the fraction. And now to tell the calculator that your next number in the next fraction over is going to be 86.9 on the bottom, and I had you copy that equation balance so that you could see what I'm doing. And actually you needed to copy the numbers where I did my calculations. But at any rate, now on the bottom we're going to put 86.9. The way you tell the calculator a number is at the bottom of a fraction is you hit the divide sign. So now I'm going to do 86.9. And now you see how quick this can go. The next number is on the bottom, so I hit the divide sign again, and that's a 2. Now the next number is on the top, so that's 99.4. And now when I hit the equal sign, I've got my number, 17.2 if I round. And that is what we were looking for as our answer, which we can go back now and put in. So 17.2 goes on this screen, and that's 17.2 grams of zinc hydroxide. And that is it. That's our answer. Thank you for watching.